it's working. Welcome. Wanted to make sure you see the note well. This is the DOTS BOF, the DDoS Open Threat Signaling BOF. Again, the note well. So we need to start with some administrative tasks. Blue sheets. I understand we already have a minute taker. Thank you. Was it Taku who agreed? Yep. Thank you. And the Jabber room seems to not yet be working, but when it is, could we have a Jabber scribe? You'll take it? Thank you. So here's the agenda. It's exactly as was posted to the mail list, so no one should be surprised. The only difference is I think we included the names of the people who will do the panel session. And over to Roman.
So we're going to have a conversation today about the problems related to the on-premises mitigation devices and how they should be communicating upstream or to some kind of mitigation provider. So the conversation is going to be focused on kind of what that endpoint should be sending around, and the thinking is at this point that it's threat and telemetry data. I mean, framing that conversation, a couple things are kind of important. It's a very kind of broad scope within a narrow area. There's probably a lot more questions than answers, but organizationally, this is a non-working group forming BOF. So what that means is that we're not talking about taking the text you see here and banging it into a very prescriptive charter to kind of move forward with. What we want to understand is, honestly, the problem we're talking about here. So next slide. So it's no surprise that the scope we're talking about here pulls other working groups in the IETF. There are probably more than are listed here, but kind of specifically of interest here is the Ops Area Working Group, because we're talking about network telemetry data and various ops matters, and then MILE because it's talking about exchanging some threat information. If there are kind of others that you think are germane here, again, when the discussion starts, by all means, kind of let's talk about those languages. That makes a lot of sense. So what you have agenda-wise is we're going to have two drafts that are going to talk about some concrete ideas in this space, and then we're going to have a panel that's going to be talking through, the applicability of not necessarily those drafts, but in standards in this area. What I would ask is, as that conversation is kind of happening, that you think about 4 questions that we're going to return to after all the formal presentations. It's first, given everything you've heard, how do you feel about understanding the problem that's been laid out? Do you feel that standardization is necessary in that problem space? And of course, implicitly, do you think standardization at the IETF is the right place to do that? Hearing what you heard, are you willing to contribute to that effort? So specifically writing those drafts, editing those drafts, providing feedback, and of course running code. And then organizationally, if there is kind of the thinking that one should move forward, to the degree where do you have ideas about where this should be done in the IETF? So we'll return to all those questions after the formal presentation, so if you could just keep those in mind as the conversation starts. So the first piece on our agenda is Nick. He's going to be talking to us about the open signaling draft. Please.
Hello? That works. Hi, my name is Nick Teague. I've put together a draft and proponent of this particular BOF. Next slide, please. So DOS stands for DDoS Open Threat Signaling. There is a draft under my name we submitted just recently. I believe there's another draft here to discuss some IPFix stuff as well that may be complementary. Next slide, please. So the landscape. DDoS mitigation is an arms race. There are bigger attacks, and to sink bigger attacks, you need more infrastructure, bigger pipes, bigger everything. Each time you get bigger stuff, the other side gets bigger stuff, and so on and so on and so forth. There are organizations, though, that don't want to keep spending the money, increasing. They can't do it because, for those 1 or 2 days a year or something when it's going to go all pear-shaped, it just doesn't really work. However, organizations are happy to deploy sophisticated on-premise mitigation devices to handle what they can handle within their infrastructure. Those devices are able to perform a number of mitigations. They can, they can do this in an automated fashion, or can alert or whatever, or they can be monitoring systems as well, which, can take feeds off local devices and again perform mitigation tasks, inject things like flow spec, etc. Some of these providers, though, they want to integrate with an upstream service provider to handle to off-ramp what they can no longer handle themselves. That might be for a number of reasons. The device might be constrained, the resources might be constrained, the device might be able to handle it. There's simply the fact that the size of the attack is just too big for whatever they can handle. The upstream service provider is assumed to have much greater bandwidth, much greater resources, a specialization in this field, and the infrastructure to be able to handle these general attacks, and that's commonly what happens. But this integration has a few challenges. Next slide, please. So the first one is that there's no real vendor-agnostic way to do this. There are methods to export data. You can use syslog, you can use flow, you can use the telephone. There's all sorts of ways to do this. But if I have a circle and I want to talk to another circle, that's fine, because vendor circle will work with vendor circle's cloud solution or service provider solution. But if I'm a square and I wanted to have my circle vendor solution talk to it, then it's not going to happen, because there is no agreed way for those to be able to express telemetry information. Now remember, this is not just flow and stuff like that. This is actually the on-premise device has already performed a bunch of analytics on the traffic. It's already maybe mitigated a chunk of traffic. It knows what's going on. Next slide. It reduces my choice as well, because if I have to look at what my provider is going to implement or has already implemented before I can buy my own implementation. Or if I buy a specific implementation for my on-premise, then I have to match that to a provider that also supports it. That can be somewhat difficult. I want to create my own DDoS protection CPU one day, maybe. How am I going to have that talk to an upstream device or upstream provider? I mean, is that going to be, is there a standard way for me to do that, or am I going to have to basically just resort to exporting flows and having the upstream perform a bunch of analytics I've already provided? Visibility. The CPE device, as I mentioned before, has a unique view on the network, both in steady state and while under attack. It knows what it's dealing with. It knows what the steady state is. It knows when bad things are happening. It's already doing all the work for you. Exposing this information to the service provider is invaluable, because currently when you swing, what tends to happen is that the service provider will get the traffic, and then it has to go through a learning experience. It has to figure out what exactly the attack was, whereas the on-premise device can actually communicate that and say, oh, hey, it's a SYN flood, so the service provider can already have the correct protections in place. So what does DOTS offer? At least what does the draft offer that we're trying to propose? So it's a vendor-agnostic approach. So if I want to code my own CPE, I can. If I want to put together an application that can do that type of thing, I can. It allows me to go out and buy a device that I want and not have to really think about how that's going to interact. Yeah. Okay. So I don't have any lock-in. I can basically go out, pick the best of breed in whatever field I want, and then have it talk to the best of breed service provider if that's what I want. Or I could have it talk to multiple service providers. I could have a couple of different ones who have different cost structures based upon the attack type or size, and then I could pick and choose whichever one I wanted to use, without having to worry about what infrastructure they had in place. It condenses a lot of the current exports and analytics into a single protocol. So you currently have like Flow, SNMP, syslog, all these things going on that are then kind of like figured out by the cloud or service provider, and then it comes up with a decision. This could be condensed down into a single export for the device, and you wouldn't need to then kind of keep kicking all these things up and and trying to extrapolate various bits of information from it as to what's going on. And it just makes it easier to share. I mean, if we have this agreed implementation, then we can start taking this information, moving it into a format, into other formats, exporting it into other formats, and it can be standardized across everything, so, well, every DDoS device. So if you want to push this data from the that you've received from the DDoS device into IODEF or MILE or any of those type of things, then you can do it in an easy way, and anybody can do it. So what is DOTS? Well, DOTS is a proposal, and it has two channels. But we're basically looking at a couple of things here. The first one is a registration, authentication, configuration of the actual of the DDoS device and the service provider and the channel, that particular channel. And we're also looking then at an IP fix export, which will handle the signaling of the DDoS attack. And that basically explains it. So the first channel, the JSON RPC API over HTTPS, is for registration and configuration exchange. The idea is that the operator will want to communicate to the upstream provider to exchange some information, keys, encryption. It could be encryption keys, it could be access tokens, it could be protected object data, and so on. The second channel is IP fix based, and it uses custom templates for heartbeat and data export while under attack. The reason why it's IP fix based and why there's two reasons why it's IP fix based actually, but there's the first one is that it's templatable, which is quite funky. So we can build templates and then export data to match those templates, and it's reasonably lightweight. And we can use something like a UDP channel for that. Why are we using two channels as well? There's the two channels have very different functions and needs. The JSON channel is fine to be HTTPS simply for the fact that it's a peacetime channel. The idea is that communication will occur when attacks aren't happening. So you can just get away with using standard methods and means. And for some stuff like, I don't know, whitelist, blacklist exchange, you might want to have like ACKs to make sure that everything's installed. The IP fix-based channel, the UDP channel, is actually there so that while under attack, the ingress links are very probably going to be congested. So to be able to get any data out via a connection-oriented means is going to be quite difficult. So you want something that you can just kick packets out and have a stream that's not reliant upon return packets or any connection-oriented protocols. So a bit about the JSON channel. So this is, as I mentioned, utilized in, of course, yeah.
No.
Is it on?
All right, just repeat the question after he says it.
Yes. Okay.
Repeat the question, please.
Sorry, Brian Trammell asked the question, are we using IPFix over UDP? Yeah, and the answer is yes. Yeah, so where was it? Okay, so you have the JSON channel. This is used for registration, authentication, if any exists, whitelist, blacklist exchange, if you want to do it that way. A dynamic allocation of the collector. The reason why we do that is so that if you have a static allocation of the collector, that could be a potential target for attack. So if you have a dynamic allocation of a collector, then the attacker finds it harder to figure out what that find it harder to figure out what that is. Communication of load factor thresholds. This is something that's kind of like we've kind of tossed around. So the service provider could specify that a bunch of load factor thresholds that it would accept, that the on-prem device could actually, once it exceeds, it will communicate. That seems a bit backwards, really. I mean, we couldn't change that. How often is the channel likely to occur? 12 hourly or daily or something like that. It doesn't have to occur that often. It's just something kind of like a call home. Is there any change? Yeah, okay, great. If not, then just carry on. CP to provider. CP basically initiates periodic connections. There's like a user role, password, or whatever, API key, standard stuff. It posts the device IP load factor aliases. The reason why we do that is because each device may have different load factor. types. One may be a CPU, one might be memory, one might have multiple CPUs, one might have multiple kind of ways of describing things. One might be buffers, another one might be call it tables, whatever. But that just like sets the alias to the service provider. The provider to the CPE. This provider responds with a bunch of stuff. Basically, an access token, which is used to identify the CPE. The export host, which was mentioned before, that's the actual IPFix collector. Whitelist IPs, thresholds, load factor, percentage of max, etc. Like I said, that's kind of like, I'm starting to doubt that one at the minute. Mitigation info. So, is the actual device, is the service provider currently inactive, monitoring, or mitigating? Inactive is that nothing's occurred and that this is the first setup. Is it monitoring, as in is it nothing going on but it's just looking at your traffic? Or is it actually mitigating, as in there's actually a mitigation already up there and it's dealing with it? The swing flag, which is true or false, as in traffic was swung or it wasn't swung. Blacklists, addresses, this is a bad IP, this is a bad IP. And then custom kind of arbitrary data, you can tag in extra stuff. This should be extensible, we should be able to add extra stuff in there, although that's not really kind of like very apparent. So the IPFix channel is where it kind of gets a bit more interesting. So it's utilized for heartbeat and actual signaling. When the device is overwhelmed or the operator's network is overwhelmed, then this is used to basically call for help. It's also used to exchange telemetry information. So there's 3 templates suggested, which is events, which summarizes the attack profile, a protected object, which details the network element, the target host subnet, and any associated relevant statistics and other kind of parameters, things like SLA values, that type of thing. And the attack threat template, which details information pertinent to the attack itself. These are tied together by a key, which is referenced later on. The event export, which is the first one we're kind of using as a heartbeat, or we're suggesting as a heartbeat initially. That can obviously change. Currently, currently the draft suggests a heartbeat, a unidirectional heartbeat. We're suggesting, after some thought, that a bidirectional heartbeat is much better. Next slide. So the event template basically looks like that. You have the access token, which is what was exchanged in the HTTPS, JSON stuff. You have the key, which is the key in this case is an identifier that's unique to the device. This could be an event, incident ID, whatever you want to call it. The time, which is the time since the event started. The type, which is the type of attack. The description, which is just a generic description. Scope. Now, scope is, I'm trying to remember what scope was. Scope was whether it was mitigating or whether it's monitoring, etc. The SOS flag is essentially a way to bypass and just call for help. If it's set, then it's a case of like, well, swing traffic out. This gives you the ability to override any thresholds-based systems or anything else. And the thresholds at the bottom is just the current thresholds that are currently being seen across memory, CPU, interfaces, buffers, whatever. Next slide. So as mentioned, the event, each event is a unique, relates to an incident. You can call it an incident, you can call it an event, you can call it whatever you want. They're tied to the attack type. Multiple attacks will be communicated as multiple events. Now, where multiple attacks are correlated by a device, because that can happen, in some instances, it's going to flag various elements of a single attack as separate incidents or events. But in this case, what other devices may see it as a single attack, but then break it down in other ways. So by that, what we suggested was that you could correlate a larger event that may be linked by using the same key across multiple records. The SOS field is provided, as mentioned, to request a mitigation by additional infrastructure or service provider. Essentially, if it's constrained, it can just cry for help. The protected object template, again, the access token, the key relating to the incident. A label is a generic label that anybody can say, like, this is my internal network. The address prefix, which is pretty self-explanatory. The protocol, TCP, UDP, whatever. Port, SLA code point is interesting because that's the ability for the device or the operator to actually communicate stuff like clause information within there. Some They may have multiple subnets being attacked. Some of those subnets or some of those services may be more important than others. Others may be, you could treat them in different ways. The mitigation status, as in what's it doing currently, is it mitigating or is it underwater, or is it not mitigating? Bandwidth threshold, as in what bandwidth threshold is being exceeded. The current PPS, the current BPS, peak BPS, typical averages, stuff like you'd see in those graphs. The attack template is quite simple. It's the access token, the key, the threat identifier, and threat data. So the access token, as mentioned before, the key relates to the event ID. Threat identifier is just a commonly agreed representation of an attack type, which I'll get to in a minute. The threat data is any additional data that you might want to include, like regexes or signatures, etc. So, as mentioned there, it includes a data field, additional. So you could include some payload information, some basic stuff in there if you want to. Next one. Thanks. So the attack definitions, and this is pretty much, I think this is pretty much next to the last slide. So in order for this disparate systems to be able to agree on what attack is being dealt to the victim, they have to agree on how those attacks are going to be identified and represented. So what we're suggesting as part of this is that we have an agreed upon set of attack names, definitions, subtypes, everything else. A dictionary is defined in the proposal, but it's obviously can be expanded, it can be changed, it's not written in stone. And also it should be extensible, and that's that we should be able to update it. We should be able to be updated dynamically somehow, but we should also be able to just update it generally as we see more attack types and more common things occur in the space. So what else? Some things we haven't really kind of figured out is encryption, how we're going to protect the data as it travels, as it traverses across the internet. There's a couple of suggestions, but that has yet to be explored. Heartbeat from the provider to the CPU, we haven't figured out that yet, but that's something that we feel is necessary, so we're not using multiple channels. Certain optimizations, can we instead of can we in JSON channel exchange prefixes and then assign them a simple number, a simple numeric value. Then when it comes down to exporting templates, we can just reference that number maybe. Some field name standardization, interoperability with IODA. So the field name standardization is currently what's there is entirely arbitrary, but what we'll need to do is obviously come up with a bunch of names that actually fit either IPFix or some other kind of standard or IODEF or whatever. And then obviously the interoperability is called out there. And that's all I have.
So we have time in the agenda for questions. Can you speak loudly and we'll just repeat the questions?
There is a dictionary, it's a dictionary definition example in the draft. As far as examples of how that would look, no, I don't have those currently. But that's something I could easily produce and distribute on the mailing list.
Can you repeat the question was?
Sorry, the question was, do we have any examples of the dictionary definitions and thresholds, etc.?
Okay, Eric Ving, Cisco. Just wondering whether the information channel under the attack is mainly from the CP to the service provider, but I'm pretty sure that the customer would like to get some feedback about the mitigation, so getting as well a channel back reporting mitigation is effective or not.
Yes, that's very true, and that's why I called it a heartbeat, and that's part of the challenge, but that's probably not a very good description. It's a heartbeat in a day-to-day operation, but during attack, then that heartbeat, which is going to be UDP, lossy anyway, can also maintain feedback from the upstream provider to say, yeah, oh, here's the incident ID that you passed to me, and here's the current some current statistics, and then that hits the device, and then that can be displayed in pretty graph. Here's your mitigation. Yeah, but yeah, that's something that's being discussed currently. I haven't called it out on the list or the thing, but yeah, you're right.
Okay, thanks.
Thank you.
Frank Shah from Huawei. One question for clarification. In your draft, you mean that the CPE can use the IPFix channel to send the attack type information to the cloud-based anti-DOS system? Yeah.
Yes.
But I'm confusing that what the type of CPE you mean here. I think this CPE must have the anti-DOS anomaly detection function. It's not a very simple basic CPE.
No, I'm not speaking about a router with a module or something like that. We're talking about a commercial or privately
a security device.
Yeah, a security-specific DDoS mitigation device.
Okay.
So this is one that would be. The idea is quite simple. You have your DDoS mitigation device in your network. You have a certain amount of bandwidth, and this DDoS mitigation device can already deal with most attacks. It's happy to deal with those attacks. But what we're dealing with here is that sometimes those attacks are far too large for your network links or some other resources. So at that point, the device becomes. At that point, the device may want to off-ramp to a provider. So yes, it's communication between a DDoS device and a DDoS mitigation provider, or a service provider that has a DDoS mitigation scrubbing center and can do both.
I also have a comment.
Yep.
I think you try to use the IPFix terminal and format to transfer the attacked type information.
Yes.
But I think it's far more access the current IPFix function. IPFix just currently IPFix mechanism just be used to transfer the flow sampling information.
Yes.
Just some statics and raw packet information. It doesn't include any so high level or high intelligence information.
No, not existing. But what we're talking about custom templates here, which can we define the template first off, which is a custom one. We export that to the provider. The provider then uses that template to determine what the data set is. The data set can be anything though. I mean, the data set is field X, field Y, field Z, and have values within that. So within that, yes, IPFix, I mean, there's a flow export, but it doesn't have to be flow export. I've seen examples of it being used for the export of other data.
Yeah. I don't say I don't agree this extension. I just want to note that it's not the traditional IPFix format. You want to do more extension.
Yeah, we're not using IP. Yeah, you're right. We're not using IPFix as we're not looking at IPFix and using IPFix as it is defined today to export all this. We're suggesting custom templates and then using IPFix as the kind of transport. Yeah, thank you.
Brian,
So before that comment, I just wanted to comment. So it felt like in that exchange, the notion of a CPE was roughly defined, what was in scope, out of scope. If there is discomfort for that, I mean, let's add this to the dialogue. But given the time constraints, I would also note, let's close the line off kind of here, and we can continue that at the end.
Brian Sniffen from Akamai. I'm very glad to see the SOS bit in there. But in terms of thresholds, part of the value for having different CPEs and different cloud providers is that they provide different control systems.
Yes.
Given that, what's the value of specifying the thresholds? Is that required? How do you deal with the fact that folks are going to interpret that so differently into different control systems?
It seemed like a good idea at the time, but really,
Does it still?
I guess the thing is, this should be a two-way thing. I think there should be the option for the operator to access the cloud provider and for them to exchange information on thresholds that way. There should also be the option, I mean, it's not called out here in its extension, but it's been discussed, is that the CPE should be able to exchange what thresholds it considers to be beyond its capabilities or at which it is at risk.
I see a lot of value in reporting telemetry on current state, and I see value in the JSON channel for configuration.
Yeah.
And so part of current state is I'm swamped, please do more,
Yeah.
Or you know, I'm kind of feeling lazy right now. You could throw more at me. But thresholds to try to configure the other control systems seem likely to be very unstable in practice when you have multiple of these data.
Yeah, I can see that, yeah. Okay. Thank you.
Andrei Rubashevsky, Internet Society. So is the idea or a possibility that those devices can be linked further? For instance, like service provider, DDoS mitigation device can talk to peers and upstream provider
I don't
and
see,
implement sort of pushback mechanism?
I don't see why not. I think that initially when I was looking at this, I was thinking very much along the lines of a DDoS device and a service provider, and that was the end of it. But from various discussions, I believe that you could chain it. You know, you could have a DDoS device to another local device, to another local device, to a cloud provider, to another cloud provider, or anything like that. You know, you could actually chain this through and have
especially if you talk about DDoS.
Yeah, I mean, exactly. So, and one of the things about this as well is, like, you know, if you've got service providers with different kind of cost structures, or you want to use the different ways, or then you can do all that as well.
Kathleen Moriarty. So I'll clarify, I had assumed that this also included routers and equipment, because I think the draft mentioned IPS boxes and other things being able to communicate data. So I think I had a little misunderstanding that cleared up here. And then my question is, there has been work before that tried to do this and it didn't take off. You know, out of Inch, it was the RID work, and that got merged into IODEF and things changed.
Yep.
What do you think is different about this work that it could take off, and is there support for it already? Is it design decisions? You know, it looks like you're not using pure IP fix. There are changes, there's templates. What's justifying these changes, and why is this good? And I'm not arguing that anything in the past was good. I'd love to see the problem fixed.
Yeah. No, firstly, regarding the draft does call out other potential devices within this. What I didn't want to do, though, is try and stretch the scope too far out, the scope of this presentation, the scope of what I'm talking about, too far beyond, because those certain devices are, you know, they're going to require work. And also I wanted to focus on the DDoS CP because it's a problem we have today, and it's a problem we can fix today. As to how this one may take off, I think it's because we have some good support. We have some good feedback from the various vendors in this field and some operators, and they generally said this is something that they want now. This is something that addresses a problem they have now, and it's something that they want to do now. And that's really what where we're going from this.
Okay, so do you have comments on the design decisions influencing that, or do you think that's not part of it because you seem amenable to some changes?
I'm reasonably amenable to some changes within it. I think the design decisions using the two channels is something that's we've already seen in some implementation, some vendor-specific implementation. It makes sense. Using IP fix is something that we've discussed or talked about outside of the around, and people seem amenable to doing it because their devices already support it. So it's a low barrier to tooling as far as a lot of the providers go. So
I agree to that, except that you're changing IP fix, right? So it's not pure.
I'm not really. No, we're not really changing.
You're not.
We're not
Okay.
changing IP fix. No, we're not altering IP fix in any way other than we're not actually altering it at all. All we're doing is we're exporting custom templates, which is part of the IP fix, capabilities anyway.
All right, thanks.
Yep.
And again, the line is closed, so please, let's bring any discussion after the current line to the general discussion after things are closed. So if the three of you can finish, and then we'll get back to the other draft.
Hi, Brian Trammell again. I love seeing anytime somebody uses the extensibility in IPFix for what it was designed for. That's actually a really cool application of the protocol. So you said you're not really using any of the existing information elements, and I was wondering why not, right? I mean, IPFix is a very good. It was designed to efficiently move information about flow state from one part of the network to the other, and in a lot of cases, you could even have a data model where you're trying to move flow state. In this case, the set of flows that are interesting to you as part of this attack. That's just a comment just to think about. Another comment to think about is that when you're under attack, if any of the interfaces that are used for reporting are those that are under attack, then using IPFix over UDP is a terrible, terrible, terrible idea. Because you're not going to get any of your data out at all. There is a profile for IPFix over SCTP. It is not very often implemented. I know that, we say in all of the IPFix RFCs, we say UDP is here for legacy purposes only. Don't use it because there's lots and lots and lots of trouble with it, and everyone uses UDP because it's kind of like what they already have.
Yeah.
For the DDoS, for this specific application, I think that's good advice to follow in 7011 and 5013 about please think very hard about whether or not this is going to work under attack if you're using UDP as the transport protocol.
Thank you.
Hi there, Pat Tarpey. Just not really questions, more observations, and I'll pose them in open spirit. First one is, are there any privacy considerations, particularly when you're aggregating this type of data across carriers in a centralized point? The second point is there a risk that you end up with false positives, particularly with blacklisting, and the unintended consequences that in effect that there could be a particular traffic profile that ends up being wrongly flagged as a denial of service attack and it's a legitimate service. And I guess really finally is the capability of CPEs, the modularity in their performance, particularly while they're under conditions, echoing the last speaker.
Yeah. So the first question was privacy.
Privacy, particularly aggregating over numerous carriers to a centralized cloud point.
Yep, that's a very good point, and that's something that we so far haven't gone very far into. There's obviously the issue with exporting that particular data out. I mean, we're assuming that this is organizational data, so it shouldn't be that's reasonably, public IP addresses and so on and so forth. Of course, nobody wants that. Wants certain things in the open as far as like, oh, hey, this IP address is being attacked by or whatever. So yeah, so that's why in the last one there I was discussing things about encryption and how we could obscure that from the general internet. There's also another thing there as far as like encryption goes and obscuring it, and that's the fact that if you've got these possibly powerful mechanisms to swing traffic away or to swing traffic back, then you want some way to authenticate and then ensure that that's protected. You don't want somebody injecting those into the network as it goes past. So that's another thing we were considering as well, and that's come out of the discussions that we've had this week. So yeah, there are concerns and there are issues, but I don't think they're insurmountable in that sense.
Just as kind of segues observation, like hop off the line, it's realization that this type of system, particularly where it's aggregating logs or telemetry data concerning denial of service, would, in my view, and this is just my personal opinion, be of great interest to law enforcement, particularly when they're building a case for prosecution.
Yeah, I mean that could be definitely useful, and that would be obviously up to whoever to release that. I don't want to make policy on that one. Sorry, what was your second question?
I can't remember now.
And I do remember what you said about the CPE as well.
Yeah, blacklisting, the ability.
Blacklisting.
Yeah, I mean, kind of false positives, the ability for this automated kind of blacklisting. It could well be there's a new novel application, it's wrongly signaled as being a denial of service condition, and we inadvertently end up blacklisting a range of IPs.
I mean, with anomaly-based detections or anything like that, that's always a risk. I mean, if something different happens, then they can freak out. Hopefully there's enough scope in that to not do that. As far as blacklist goes, then blacklists do not have to be accepted, and I would just hope that there was a degree of due diligence on the side of a provider providing a blacklist, that they could, somehow that they would stand behind as like, oh, I'm going to give you this blacklist on, by the way, if it breaks your network, you can't sue me or whatever. And from the device, then I suppose if the device exports a blacklist to the CPE exports a blacklist to the provider, then it's probably already initiated that blacklist itself in some way, or is treating the traffic on that list is slightly differently. In which case, when it gets to the provider, there's no difference between what it was doing before than what it's doing now. So there are some concerns, and again, that's something that we could explore. But I think that the problem isn't one that again we couldn't figure out. On the CPE constraints and things like that, a lot of these devices are capable of dealing with traffic load up to 10, 20 gig or something like that. So I'm not too bothered about. I would expect them to be deployed responsibly, so that they're not. You haven't got a 10 gig on the end of a 40 gig or something like that. Just what you look. So yeah. Thank you.
If we could just press towards closure here, so we can continue the dialogue.
Flamy Andreas and Cisco. Just speaking to Kathleen's question before about, why do we think this might take off this time? From my point of view, I think what has really changed is the overall market and threat landscape, right? I mean, DDoS is a real issue today. We know that in order to mitigate the attacks, which are ever increasing in size, as you pointed out, you need an end-to-end solution, and you are locked into essentially a single vendor ecosystem today. If you're trying to build up an end-to-end DDoS solution, it's very difficult to do it today, right? Because you don't have this open signaling. So there are a lot of limitations. So I see certainly from the, I would say, customer side of things, I would think that there's a lot of interest in this, and this is one of the key differences why I think this might take off.
Thank you.
Thank you for all that feedback. We're going to switch now to the second draft, Anna.
Hello. Hi, everyone. My name is Anna. I'm from Huawei. Today I'm... Okay. Here? Okay. Okay. So my presentation is about using IPFix to inspect network security. Next slide, please. Okay. As we are all security guys, we know that how the traditional volumetric flood attack grows nowadays. It may grow rapidly in size of dozens or even hundreds of gigabits per second. And the DDoS attacks are becoming more and more sophisticated nowadays. And new attacks emerge very quickly. So as the attacks evolved, we need to find a solution to meet those new attacks. And we need to find out an efficient way to detect the attacks. Next slide, please. And in order to detect those attacks and identify the types of attacks efficiently, we need to find a way to model the data elements that really matters to evaluate the attacks. And when we searched at IETF, we found that IPFix is the ideal choice. As it defined all the requirement draft, protocol draft, information model draft, and the sampling policies, and they are all RFCs there, and it also defines how IP flow information is to be formatted and transferred from the exporter to the collector. And in the requirement document, it mentioned that one of the target applications of IPFix is attack and intrusion detection. And that explains why our solution intends to use IPFix as a metric to observe the metrics. The next slide. And this slide shows the workflow of how we combine the flow sampling with the big data mining procedure and the control of the policies. As you can see, it starts from the flow sampling, and all the flows are sampled and records are forwarded to the data mining center, where the flows are first analyzed on some anomalies, such as the a sudden increase of the latency and a sudden increase of the sync packet and so on. And then all the anomalies are fetched by the chaos grain detection. And the anomalies of the sessions will be detected further, and the abnormal subnets are located. And then the controller will decide how to change the sampling policy in order to observe a certain flow, goes through the network. And once enough data are fetched, the fine-grained detection will be launched, where it can precisely locate the attack source and locate the attack target, and so on. And then the policies will be generated, such as to block the traffic directly or to steer the traffic to the clean data center, and so on. So this flow sampling and data mining and the control center, they construct a closed loop which allows us to make an efficient feedback from the sampling to the control. Okay, next slide, please. And this is the deployment example. Shows that how the big data analysis platform is deployed. As you can see, it can be deployed at the core or backbone of the operator network. And it also shows that the original traffic are fetched and aggregated by the network elements. And then all the flows are sampled by them and forwarded to the big data analysis platform and to realize data analysis and detect the attacks. And then the central server will decide whether the sampling policy will be changed or where should further traffic go. And next slide, please. But as we implementing the IPFix in such kind of solution, we find that there are several challenges. First is the sampling policy. They may need to be adapted because different type of attack has different kind of feature. So we need a mechanism to adapt them in a flexible way. So that's why we move it to the central server and let the central server to decide how the policy will be. And the second problem is that IPFix lacks support of correlated bidirectional sampling. Usually, all the sampling are realized without any direction concept. And there's a RFC for IPFix shows that we can export bidirectional flow information, but those sampling are not correlated pretty well. They are sampled in an independent way. So our purpose is that once a connection is built or established, the communication is in a bidirectional way, and all the packets in that flow should be observed. So that's the second challenge of IPFix. And the third challenge is that the current information element is insufficient to detect and identify the attacks, which will impact the efficiency of to generate the countermeasure policies. Next slide. So our solution is that we can allow the central server to decide the sampling policy, and we also propose a sampling method that is complementary to the current sampling policy. It's called complete correlated bidirectional sampling. It means that it records all the bidirectional packets once that bidirectional flow is selected to be sampled. Sorry, it's a little bit too long, so I hope you understand this pretty well. And take TCP packets as an example. Once the TCP connection is needed to be observed, all the packets, like from the starting of the connection to the close of the connection, should be observed. And that's the purpose of this method. The other thing is that new information elements should be defined or extended in order to observe different attacks. Next slide. And these are some examples showing how we extend the information elements. We use a packet upstream counter and the downstream counter to evaluate the equivalent ratio of the ICMP attack or TCP attack. And we also extend some fragment in error information, like the fragment incomplete counter and the first fragment too short counter and so on, in order to identify the fragment attack. And the others are for application error code count. It's just to count how many errors occur in the HTTP in order to identify whether it's an attack or not, or just a simple event that's driven by a news that user intend to, many users simultaneously access a data server. And the last is to extend the flow and reason. And this is for our purpose only. We extend the value 06 to protocol exception timeout is for TCP attack. Next slide. And we submit this draft to IPFix, but it's now concluded. So, and then we've discovered DOS as maybe a good place to do this work. So I think from the objective of the work, we think we both want to use the similar method, that is to collect and exchange attack-related information between different network elements. And that's all. Question?
Okay, thanks, Anna. We have time maybe for one question. In that case, thanks, Anna. keep thinking about this. We can bring this up in the general discussion we have. And so this leaves us now with the last formal piece of the agenda, which is the panel. Nick, if you could bring the panelists together.
Oh, you got one there. So we have a panel here. I'll introduce them. First of all, we have Rich Groves from A10. We have Andrew Mortensen from Arbor, Vince Burke from FlowTrack, Ramakant Pandrangi from VeriSign, oddly enough. I should know that. You'd think, wouldn't you? and Dave Larson from Carrero. The reason why we have them here is to basically just to demonstrate the support we have for this particular effort somehow. And I basically have two questions for them. The first one, which I'd like to ask, and I can just start with Rich, and we can move down, is first of all, why are you interested in an IETF standard for DOTS, for this type of signaling? And how would it improve things? How would it make the internet better? How does it make DDoS mitigation better, within the sphere?
So, I think the way that the way I think about this is it turns into more of an exchange of security policy across disparate devices. DDoS is definitely one use case, and we're extremely interested in making this successful from the A10 perspective. But there's also a need for communicating policy information for lack of a better term, security sort of service chaining through a fabric, right? Understanding capabilities of a device and sending information to that device to execute a policy. I know it's kind of nebulous answer, but if I want to approach it from not just a DDoS, but we sell a bunch of different products, so that sit at different places in the network, and ideally, if I have a standard for sending policy to the correct placement in the infrastructure, whether it's a router or a DDoS mitigation device or even a switch or a WAF or something like that, then I think this makes a lot of sense, not just for the vendor, but for the customer as well.
All right, well, I think it comes down, at least from Arbor's perspective, to the fact that DDoS bad, and I don't think anybody's going to disagree with that, but the idea is that DDoS is endemic to the internet at this point, and we do need to work together to fight it. And Arbor's got some things already implemented, but we're excited about the possibility of seeing this expanded. We think there are a lot of opportunities here to improve the state of protection on the internet, and we look forward to working on this.
The way I look at it, or at least the way we look at it from a perspective from our customers is, there's many problems that the internet faced in the early days, and the IETF as an organization has picked up on those, and we've all worked together to try to resolve those. The initial problems being reliable delivery of packets, sessionization of traffic, and then we moved on all the way to the area we're obviously in, which is handling of flow data, how to export that, how to knowing that everybody has different devices in their network, how do we get some kind of uniform view and everybody follows the same standards? So we created IPFix. DDoS has become such an absolute abuse of the internet. We see it so ubiquitously, and it's so easy to do. And since the internet's become a complete superhighway for everybody who's got the money for bandwidth to use it and abuse it, that I think it's irresponsible to build vendor stovepipe solutions only in this. And you know, we realize that the problem is so big because people are making a lot of money in this space right now, but it's, you know, our shared responsibility to come up with a way to handle this. And you know, I'm saying this because my customers see this. You know, we see how difficult it is to solve this problem, but because it's become an internet-wide problem, I think it's our shared responsibility to do something about it. So thanks for taking the first steps in that.
Hi. From, you know, like, we've all seen attacks getting bigger and more complex, and that, sorry, I said we've all seen attacks getting bigger and more complex, right? And then when we looked at it, we realized that, you know, essentially the architecture that's needed needs to fundamentally change, right? It's got to fundamentally change where we have to enable like different architectures and ecosystems, and this is coming from customer feedback, right? So not every customer's data center or origin site looks the same. In certain cases, it makes sense for them to deploy, you know, a particular device, and it could be a DDoS mitigation device. In another case, you want to be able to signal because the application itself is under load, right? And these are customers, and a lot of us have built like monitoring systems that are monitoring what's happening at the end application. But if you look at today's solutions, there was no way to use this hybrid approach, right? The hybrid approach of taking information that's available on-premise or at origin sites and being able to combine that with a service provider. And from our perspective, that, you know, that enabling this sort of an architecture will allow us to be more effective at being able to counter these attacks, and also it will increase the speed of response. The more information that's shared between these devices, whether it's on-prem, like, you know, for example, there could be a monitoring solution that's looking at every single flow entry, and it knows something about the attack even before, you know, another layer would know about it, right? Similarly, an application layer might be seeing a CPU increase. And if we can enable these transactions, or we enable this information to be shared, we will be more effective. So that's sort of the perspective of why this approach, or why this architecture, you know, and what it would enable, right? And for us, the idea of IETF coming here is we'd like a standard. We want it to be lightweight. We want it to be focused, and we want to be able to deploy it and get this into production, you know, really quickly. We're looking at a compressed timeline. We're not looking at a very complex, you know, protocol. We want this to be focused and lightweight to solve this very important challenge.
Yeah, I don't have too much to add to what has been said. The only thing that I would add is that I think this kind of a federation mechanism, for lack of a better word, allows for better understanding and utilization of local context on the premise. It allows us to get away from strictly sampling mechanisms and have better information of what's happening in real time and coordinate that from on-premise to the cloud, and then ultimately have a hybrid solution that's well coordinated, both in terms of what it is mitigating and also what it's reporting, so that you can have a good understanding of what is actually happening, as opposed to I see these things in my local logs and then I have reason to believe that I need to swing to the cloud, when in fact maybe I don't. Maybe it's something else that's better mitigated in a local sense. If we share this information using this kind of a mechanism, I think we're going to be much faster at responding to the evolution of the threat landscape itself.
Thank you. And the other question I had, and again, we'll just run down the line because I have no imagination whatsoever, is, I mean, you can randomize it if you want. That's entirely up to you. I'll just toss it. I'll turn around, throw it. In what ways are you willing to contribute to DOTS and the overall effort within the IETF?
So we've already started working on an external scripting mechanism from our product to be able to script against, you know, this particular API. And we already have templated, you know, IPFix capabilities, you know, so taking whatever eventing information or time series data that we have to put is actually pretty trivial for us, and it's a pretty short order thing. So we're very committed to helping, not just in the IETF process, but pushing it into production environments as well.
So we got involved a little bit late in the game. So a lot of this was relatively new to us very recently. And to be blunt, the current draft doesn't necessarily meet all of Arbor's needs, but we are committed to helping shape the result into something that we hopefully will be able to consume. We intend to devote some resources into that effort, and will be available and will be contributing to this work.
So for me, this is much more self-serving. Flotrix sits more on the visibility detection end and target characterization end of the DDoS space. So I have a group of engineers that are pulling their hairs out, trying to integrate with many different devices and capabilities. An open standard would make that life much easier.
Yeah, from our perspective, as I mentioned, our customers have different kinds of devices, and they're considering different kinds of devices from different vendors. Each of them good at different things. So we've already got. We want to do a phased approach. We already have a basic version of the API, that we created and enabled in our service. We are working with, with different device vendors, and we're looking to, get some integration. Actually, we have a very early integration, and Dave can talk a little bit more about that. And we're working to expand that. And Nick is obviously, at VeriSign and committed to getting this draft through.
Yeah, as Ramakant said, we are already implementing and testing some capabilities that are a reasonable facsimile of the desire or the aspirations of this draft document. Clearly, it's going to require commitment from multiple entities, folks like my company, which do on-premise detection and mitigation, and cloud entities, and ability to make sure that there is some measure of interoperability, that the requirements are not simply created based on the needs of a specific entity. So the good news is there's a lot of people in this room here today, so clearly this topic is of interest to folks, and we're committed to participating in any kind of open environment that's going to try to develop this. So to whatever extent that we can help in the IETF, we're committed to it.
I think you've summed it up very well, but is there anything else anybody wants to add before I hand it back to the chairs?
Questions from the audience?
Kathleen Moriarty. So listening to this, and just having this panel here, I want to be able to ask this question, which is a little tangential, but once you have this capability, is there interest in integrating with existing mitigation efforts like DDoS, for instance? It could have to do with botnets, and there's a group that helps with taking down botnets. Would there be interest in going from this detection and immediate mitigation to stopping DDoS to coordinating with other such groups to stop such activities, at least, or clean up those, botnet hosts, command and control servers? And
I think that this kind of metadata generally is invaluable to informing that kind of activity. I don't think it necessarily needs to be a requirement of any development of this kind of a specification or draft.
Yep, wasn't
but I
asking
absolutely
that.
agree with you. If we want to get out ahead of and remove this notion of botnets, or just frankly understand the extent of the threat landscape from a DDoS perspective, just itself, this kind of federated information is way better than some kind of a private communication channel where everything is encapsulated in a format that cannot easily be shared.
Okay.
Before we go to audio, can you identify yourself?
Finsberg, FlowTrack. I think the reason this is driven out of the DDoS protection mitigation space is because there's such an opportunity to do this right now. Like when it comes to spam propagation, botnet, command and control malware sites, there are many resources out there that help us, see what they are and where they are, and it's up to everybody to make sure you don't communicate with those, right? So, the point here being is that people ought to be responsible for their egress filtering. Do we need a signaling interface or draft that addresses that? perhaps. I'm not sure if that's as relevant. The driving force here is DDoS, not necessarily, botnet mitigation, because truly there's a lot we can already do about that.
Oh, I just meant coordinating the information you're getting so that those other groups who are cleaning up the actual hosts could take actions.
Yeah, I agree. I think that kind of goes back to the earlier thinking around capabilities exchanges. Being able to automatically instantiate some sinkhole for a command and control, like maybe what you're talking about, would be fantastic. And I think it is relevant, at least as far as the capabilities exchange discussion.
Great. So shameless plug, the Karis workshop is going to try to coordinate these types of activities and get lots of smart folks in the room like you guys to look at that bigger picture. Papers are due by April 2nd. It's an IAB workshop. What? or template formats too, if you're doing a sharing effort.
Tobias Gondrom. Yeah, and I'll also be interested in that workshop. I'm trying to kind of narrow things down on how would this look like, in what kind of protocols would we want to deploy and develop for this. And because I always try to think how this would look like on the wire, or what do we need to do actually. And just so I can confirm with you whether that is what you also see, I understood you would like to have something to collect sampling data, to submit and communicate capabilities of a device to a central point, and to later set policies to the devices to potentially change that. Does that capture what you are looking for, or do you look for more that I did miss so far?
I don't think we're, sorry? Yeah, I don't think.
Question to the panel. So, yeah. But if there's no answer, that's fine too. I mean,
I think that that's a fine core requirement. Just have to think about it a little bit more. But as far as the base requirement, I think that makes sense.
Yeah, I think there needs to be some emphasis that's not addressed in the draft on the need for policy from the CPE to be provided upstream, and the possibility of, I think it was brought up earlier, the telemetry from upstream to the CPE. In particular, what is the upstream element doing on behalf of the CPE? And I'm not sure if that is covered.
Yeah, I don't see this so much about sampling or being able to encapsulate sample data and then express it upstream. More of the metadata about what is being sampled locally, so that it can be sent and compressed in actionable format to something in the cloud, so that when traffic is redirected to that environment, it has a good understanding of what it's receiving so that it can act on it. Nick, you agree with that?
Yeah, we're not so much sending the sample data up for analysis. We're sending the already analyzed data up for action, I guess is one way to look at it, or further analysis, I guess is one way. So we're not actually sampling the packets and then sending counters and everything else. It's an actionable definition that the device has been handling.
Hi, sir. Brian Trammell again. That actually halfway answered the question that I was going to ask, but I'll ask it anyway. So we've got 5 panelists that have, I presume, at least 5 solutions that are operating in this space, or will be soon today. So I mean, we have things that are, we've got running code here. If we're talking about building protocols for interoperability between 2 different elements in each of the architectures that have already independently evolved, we need to make sure that the architectures of each of these systems are at least basically compatible. And the one incompatibility I've already seen is that you've got an architecture in the draft right now that's talking about having a unidirectional reporting protocol from the CPE back up into the cloud. Yep. And we have at least one vendor with that requires bidirectional, or would very much like to have bidirectional, because the CPE actually is going to, I'm guessing, do additional analysis or some other thing based. That's part of a closed control feedback loop that is going to do something else based on what the cloud's already doing for it, correct? So if you've got the box and line diagram with the arrowheads on it, and the arrowheads don't match up and the boxes and lines don't match up, then the protocol's not going to help you. Yes. So I would suggest, if this goes forward, Probably you need to take what you have and say, okay, prototype, that's cool. Probably we're going to use IPFix because we already have it in all the places. Probably we're going to use JSON because we already have all those parsers. You want to use code that works, but then step back and make sure that the simple intersection architecture that you have that you're going to run this protocol on is actually implemented by all the places you want to run it, because that seems like a risk to me.
Yeah, no, that's a very valid point. I don't know if anybody else wants to comment, but I think we have a 00 draft now, and we've been talking about it with, like Andrew and Rich and everybody else. And so as we're discussing this more, we're getting more feedback, and your point is absolutely spot on. We need to make sure that it's going to work for everybody.
This is Linda Dumper from Huawei. And first of all, I like this approach. And I heard the panelists talking about you have a multiple security function and DDoS in the network. So how do you consolidate them? How do you give the policy to each of them, right? So my question is, since we have another initiative with similar domain, sending the policy to those functions, are you suggesting using IPX to do it, or is there some other approach, like giving the policy to those devices?
So, sorry, is the question, are we considering using IPFix to distribute the policy across those devices?
Right.
Rich?
I do think it's a fine way to do it, but I do think that each one of the devices will have a certain range of capabilities.
Mm-hmm.
And so we have to figure out a method to make sure that those capabilities are expressed and informed to the, to the sender, I guess is what I would think. And so I'm not entirely sure that IPFix is the only thing that's needed there, but I think that we'll learn that along the journey as well.
So what do you think about NetConf to distribute those policies? Is that a viable approach?
Yeah, I mean, I think that NetConf is definitely a viable approach. There's in general, I know this is going to make me not very popular in this crowd, but from what I've seen, at least in the customer space, people are try to be pretty stiff-armed about using NetConf. So that's something that we'll have to explore, but NetConf is definitely something that could be used. My problem, though, is making sure that this signaling works through some slew of middle boxes, right? Because there's going to be a large number of middle boxes. I make some, other people make some. And so we have to have a transport mechanism that works pretty well for that.
Thank you.
Rich actually caught half of my comment there, but I'll augment that. Like the case we're trying to solve for here is where some of the customers will have on-premise equipment that can handle some either volumes or some types of attacks. There's going to be moments when the device there or the software there realizes it can no longer handle this. Right? At this point, any information we have available on the attack can be signaled up to a cloud provider or an upstream provider. It doesn't even have to be the cloud provider. May allow them to select specifically what mitigation they'll put in place. And yes, there is the possibility they'll do additional analysis at this point, decide whether or not a different mitigation is needed, but it gets you one step ahead of that. Now, the question whether IPFix is the right format for that, I cannot quite answer, but it's a stake in the ground we've taken.
And I want to clarify on this. I think one thing we have been purposely a little careful about is people need different kinds of workflows, and we're not looking at this protocol to solve that or to specify all those workflows, right? So as a service provider, you might have a customer who says, above a certain threshold, just auto mitigate for me and it's all great, right? That may be unacceptable for another range of customers based on what their situation is. So what we were looking, I think one of the goals when we're defining the protocol is to ensure information can be exchanged and it's rich enough that on both ends, whether it's on the premise end with the CPU devices or on the service provider end, people can then build workflows and do additional value add there. We're not looking for all of that information to be encapsulated or all those, that sort of orchestration to be all enabled within this, right? There is, I think that can stay outside. That's.
I think I would just add to that the idea of trying to change the configuration during an attack is not ideal. So modifying let's say the prefixes or what elements you want protected while you're under attack does not seem ideal to me, and that is something that is covered by the HDVS peacetime channel.
Yeah, I was going to agree with that. I don't see the basic benefit of this endeavor to be about the protocols and about configuration. I see it more about signaling and about schema. The most important thing in an environment where there are heterogeneous participants in the enforcement of DDoS mitigation is that they can agree about their capabilities and that they can share information about what they are dealing with or mitigating at any given time. So frankly, the selection of IPFix, the selection of JSON, the selection or the alternates to use something like netconf are less important to me than the actual agreed upon schema that can be instantiated upon any carrying protocol.
Okay, thank you. Next question.
So I think we all agree that it's an important issue to solve. We have to share some information. But what really we want to do that the right way. And we need that to be extensible in the future, and we also need that to address any scenarios. So from the presentation and the drafts, I think it's a very good, probably a very good starting point because there are a lot of work in that. But what I'm not so much convinced, but I cannot say it's bad, or is that we're doing it in absolutely right way. And there are many things to do, and maybe we should split them into different, not to have a world pack solution that is a kind of, that can be changed in the future easily or so on. So that's the only fear I have toward the solutions that have been presented. And maybe we should really define the scope, but it looks like we kind of all agree on the high-level goals. So that should be just go from the high-level perspective to the right protocols and the right templates, and then ongoing work will find the right solution at the end, I think.
So I'm going to cut off the line. I mean, before you answer, I'm going to cut off the line just so we can get to the point of kind of talking about the questions again.
Next.
Alex Grabanov, Nokia. I have a question about the signatures. Who is going to define the attack signatures and who is going to update them?
So the signatures, the question is who's going to define the signatures and who's going to update them? And we've already taken a stab in the draft at a bunch of common stuff, you know. But that's, and this is something that we need to do. We need to be able to communicate, you know, if device A is communicating to device B and it's using a different description, then device B doesn't know what device A is trying to say and so on. And that's important that we along with this process, that for this particular implementation that we define those, and that should be part of the process as it goes along. That could be, you know, I'm as far as where we record it, we could record it within IANA. As far as how will we do it, then I think that's open to discussion, and it's something that we need to just have as an ongoing working document. It needs to be something that is constantly updated as new things occur. We can't just say, oh, this is all the attacks you'll ever see, because that's not correct. Or we make it suitably, or we come up with some other way and figure out a way to communicate, but I'm not sure what that is right now.
But you are going to work with this?
If this goes ahead, yes.
Mm-hmm. Okay.
Does anybody else want to comment on?
Welcome back to Telecom. I think this is good work, but whenever I read about a draft that calls for the CPE to contact periodically a server somewhere in the cloud, I get a bit nervous, because if you have 10 million CPEs and everybody have to talk once an hour with the server, it's quite a big load. And most of the time we don't have denial of service, and I just ask for a mechanism that doesn't put too many permanent load on the server infrastructure.
You know, that's a good point, and I was just thinking about that the other day actually, because you know, if you install all your devices at once and then you turn all your devices on at once, or you upgrade them all at once or something, and then they're all going to go off and do everything at the same time, and probably that counter starts ticking down, and they do the next thing at the same time. So some in that needs to be clearly defined, because at the minute it's kind of like periodically, which is a very vague term. Yeah.
Yeah. More importantly, I think. To me, there's no, today we do sampling of the edge network in order to determine what's going on, and that's very heavyweight and it's very data intensive. If you move to a model where the on-premise solution encapsulated in and of itself knows what's going on and is only communicating metadata in a very periodic and maybe a very quiet way, it actually reduces that problem to some degree and only asks for a switch when something is going on that requires it. In addition, this is not based on ad hoc federation. In all likelihood, this is agreed upon federation. So the scaling elements are under control of whatever contractual environments are in place for providing a unified solution that includes on-prem and cloud.
And to add to that, I think, you know, like when we start looking at practical deployments or like looking at architectures, I think what's important is we are saying CPU, right? But in certain cases, it's a logical unit. There could be like 8 devices or 10 devices, but you have something controlling that, right? So at that point, what would actually be doing the signaling is not necessarily the individual device, and this architecture doesn't require that, right? It could be the controlling element or you know, the management element that is actually doing that integration with the upstream provider. So I think it's a logical element in a lot of deployment cases in reality.
Thank you. Yep.
Tobias Gunrum again, this time in brackets in association with Huawei. So I'm associated to them, that's what I mean. When I looked at both the drafts and hear the discussion at the moment, I have the feeling that the first draft, basically our discussion right now, is more like for very intelligent denial of service devices, while the second presentation reflected quite more simple nodes in the network for this communication. And I would like to encourage the protocol development to cover both. So it should not be required that you have a very highly intelligent kind of aggregation of data before you can transmit. This should consider that you may have a large number of nodes that are sampling the data. So we should have both approaches covered with that. That would be my comment.
And I think we absolutely agree. And one of the reasons there is an SOS flag there and a lot of these elements are optional is because depending on the kind of device capability you have, like if for a certain environment it makes sense to have a sophisticated device, it can support that. But for different other environments that customers might have, all they may have is the capability to say, I need DDoS protection. And it's okay just to have that signal as well. So the protocol supports that.
That's all I have.
Perfect. We really appreciate your participation on the panel. It was a real help in framing the discussion. Thanks so much. So as we think about next steps, I think this conversation has been really helpful in defining scope. Some of the things that I caught were, and honestly I'd be really interested if folks kind of came up if there is an agreement on this, is that some of the protocols we're talking about would be interested in sending capabilities from a CPE up to the service provider. The CPE would also have to be sending observations or telemetry up, and the service provider would then be sending down policy and then potentially sending down what it's doing about all those things being sent up to describe the mitigation activities. So if there's further discussion and that's not the scope of what we're talking about, I mean, please let's start having that conversation. And then we've had some discussion on what it actually means to be a CPE, and we've been going back and forth about how specialized this device needs to be. So I think we ended up with we want both specialized denial of service mitigation devices, but also more lighter weight devices also involved here. And the last kind of comment, and if anyone else wants to talk about this as well, seemed to be around how important is it to be, fixed on its IP fix versus something else, it's JSON versus kind of something else. So how important a particular representation kind of might be. So if there's further thoughts on that as well, I'd be really interested. And again, the framing things we want to get to is, do we understand the scopes kind of sufficiently, and then we figure out what next to do with standardization.
Fleming Andreas, just to the protocol question, actually not answering so much whether it should be IPFix or something else, but there's one concern I have listening to the discussion. There seem to be a lot of people focusing in on the specific mechanisms that were proposed in one particular draft, as opposed to taking a step back and just saying, look, we have a problem here, right? There is, one way of solving it here with this particular draft. I could come up with a bunch of comments on them. I don't think that's terribly important at this stage in the process. I think we need to focus on what is the problem as you're outlining here. Do we think there is a problem, and do we want to develop a solution for it? And we have some input to that, but by no means does that mean that that's what we're going to be doing, right?
Thank you.
Bob Moskowitz, HTT Consulting. When I look at this and some of the comments that have been made and the scaling that we can get up to, I'm looking at the trust. Why should this message, this information be trusted? How are we going to prove the trust, and how is it going to scale up, and how does the trust mechanism does not become a attack surface itself? That, hey, if I can knock down the coordinator for this, then all the CPU devices have to set up their security associations again, or whatever. So in these discussions, it's not just how do you identify the types of information you want to send and how you're going to send it, but how you're going to do a trust model which is going to work in this environment on this scale.
So, Bob, I just want to make sure I'm interpreting your words properly. Are you saying how do we make sure that we're not creating an even more attractive DDoS target?
Yes. Replace one with another, and that's even easier.
Yeah, I mean, very clearly we're talking about exchanging threat information and mitigating it. We need to figure out the threat model for the thing that's exchanging all that. So, I mean, we, if nothing else, have almost no security considerations on either of these, and we need to walk through that in addition to the privacy considerations that were also mentioned. Other thoughts? Any thoughts on, any commentary anyone would like to kind of render on the questions we have up there sitting on the slides? Can you use the back mic? That one's not hot. No.
Well, with this question, I just want to know if the protocols that have been presented should be, well, like adopted as working group documents, or no. Well, the question I basically have is, well, if we answer, given the different answers that's going to be provided, will we have something like defining the requirements or this kind of stuff, or are we going to jump directly from the proposition that have been presented to?
So this is not a working group forming BOF, right?
Okay.
So we're trying to understand whether this is a problem that there's adequate interest in working on and adequate energy in the room to work on, and a problem we all agree deserves work on. So if we get adequate support for all of the, across the whole front of that, then there might be another BOF that talks about the charter and the milestones and those so on.
Okay, right. Perfect. Thanks.
It's time to ask the questions then. So can we have the room hum? Do you think we sufficiently understand the problem space? Hum now, please. If you don't think we understand the scope, can you hum now? So it sounds from what we just heard that it's tipping that we do understand. The consensus appears to be that we do understand the problem. So the next question is, how do we feel about standardizing this? Is this something that the IETF should be in the business of standardizing? If you believe yes, could you please hum now? For those that don't want to standardize in the IETF, could you please hum now? I think that's a resounding that this should be standardized in the IETF.
Even from the people who didn't think they understood the problem.
So Brian, a word, yes?
I was one of the people who hummed for the no on the first one and yes on the second one. I want to explain that hum.
Defend your position, please. Yes.
I think the problem spaces we discussed it on the panel seems to be fairly well understood, and I think that it's very clear that all the people who would be contributing here, I'm assuming that they would be part of the core of this effort, understand where the pitfalls here can be and understand where they need to put the work. The edges of the problem space I don't really think we discussed very much, right? I hummed for yes on standardization because if we draw the box in the more restricted way that we were talking about it today, then I think that it could actually succeed. We might miss an opportunity for doing something a little bit on the edge, but that's better than trying to boil 6 oceans at once.
So is that, Brian, the same way of saying there's interest to do something kind of in this space? We don't have the really rigid scope, and if we were to go kind of further, there's the conversation we had, what will be in and what's out. Further commentary. The other mic's hot.
Ed Lopez with Fortinet. I was another one who hummed no on the first and yes on the second. I think that when I look at this, and we're specifically talking about DDoS, but I'm looking at the broader scope of just general network security functions. I know there's another BOF about interface network security functions and such, but I think that whether you talk about DDoS, whether you talk about other functions, whatever they may be, we are now moving towards starting to move towards networking environments involving programmable forwarding planes. And when you start moving into that SDN type architecture, the application control data plane architecture, the need, this is why I hummed yes on the second, the need to honestly standardize on those interfaces is crystal clear. I'm not sure if we understand fully. I think actually DDoS to me is actually kind of limiting in scope. But the thing is, I think that those interfaces absolutely need to be worked on.
Thank you for those observations. So to the next kind of question, and could we do this by raising hands? Who would be willing to work on it? And working on it, again, means any number of things. At first, working on the drafts themselves as in editors, also folks providing feedback on those, and then running code associated with it. So if we see a show of hands, please.
A significant number.
Yeah,
at least half the work.
So to that kind of last question, do folks have thoughts about what to do kind of next? I mean, how would this best manifest itself in the IETF?
So one of the things is form a new working group. Another one is, this looks like it belongs in an existing working group, and that group should be rechartered. So we're looking just for brainstorming on that thought.
AD submission.
Can we start a working group on this, please?
Dan Wing, one of the problems seems to be a schema that needs to be better done than what's here today, and we need some ops help for that.
Good point.
So Danny McPherson, I was going to agree with Sean. Actually, I don't know why this was a non-working group forming BOF, except that the scope isn't defined, and I do believe we need to define the scope pretty carefully because even in the room, the first set of presentations and the second set are very different things, much less if you're talking about like NFV or SDN or other things as opposed to sort of this one practical aspect, which may itself even mean lots of stuff, lots of different stuff to different people. So I'd be for forming a working group. I don't know why we would want to have another BOF, but I actually think that we need to be really tight on the charter. Some of the reasons other things died in the IETF or elsewhere are because they sort of try to boil the ocean, like some of the stuff Kathleen talked about. So I think we need to be really tight on the scope.
So before you sit down, when you say be really tight on the charter, what I think I'm hearing is pick the one use case, two use cases, get those working, and then if we see success in that, do something else.
And if it goes from there, maybe. But I mean, at the NFV or for the SDN stuff, and you're moving way outside of that initially, then we're never going to get anything done.
Thank you.
Thank you.
Sure. And Kathleen Moriarty. So I'm the AD. The reason why this was a non-working group forming is that it was requested that way. It came in very late, so this pulled together nicely. It was great to see the discussions. But the way that it came in, it definitely wasn't presenting as a working group forming. Now, there's no reason that another BOF would be needed if the energy in the working or on the list shows that this can be done quickly. A charter is pulled together. We don't necessarily have to have another BOF. If it all lines up, it could happen before the next meeting, and we've done that, right? So Tokebind is an example.
A key point that she said was activity on the list.
Russ, you said a charter working group or recharter OTA working groups or what have you. Is there some information in terms of what other working groups this may end up besides recharting IP fix? Okay.
During the opening remarks, the point was made that these two have some overlap. The point that Danny made was, no, let's pick a narrow thing and work on that. So it depends as part of that discussion how that would go.
Just raising it. Okay, fine. Thank you.
Sure.
Kathleen Moriarty again. One of the benefits from MILE, but the group can also take that work, is the threat space against the actual boxes doing this was really well thought out through MILE. So I'm sure there'd be additions, but there's a body of work from the IETF that could be used. So there are some correlations, but this was separated out because we wanted operators involved and to see this. We didn't want to bury this within another working group for this meeting.
Yeah. Tobias Gollum again. So there was I'm not sure the list is kind of catching everything, the list of other activities. There was a BOF, I think, at IETF 91, I2SF, and I attended, yesterday there was a BABOF meeting with like 20 operators and users there, and I think my feeling is there's certain synergy between both. I'm not sure which way, but yeah, so maybe you should consider how you want to do this. I mean, separate is fine, or whether you both can benefit from each other.
Right, so I'll keep an eye on that. I'm the AD that's helping on both of these. While there are some similarities, there's a lot of differences as well. So sometimes it helps to break problems out and get them tackled in separate working groups. I2NSF isn't far enough along yet to become a working group, and hopefully the meetings this week are helping them to improve the work and correlate it more to progress it so that it could be a working group. And then we'll see more of the similarities as these both evolve and see if something should be together or complementary. We always put markers in new working groups, of other working groups they need to pay attention to, and that's an important thing to do, right? We don't want to create the wheel in multiple places.
If I may make an observation to that, yesterday, actually, a number the batteries. Oh, okay. A number of the things that we discussed today reminded me of what was talked there yesterday. So actually, well, I'm not sure that this is more advanced than the discussions I heard yesterday, and I was just kind of joining that whole conversation. So about that perception, I may have a different observation.
Right, and I did not go to that. That was an unofficial one, and there's another unofficial one tomorrow night. So I'll see what happens there and see what progress has been made. And yes, progress has been made in that group with implementations and other things, but they were different, right? That's an OpenStack thing, and these guys are looking at APIs and IPFix, so they're different right now when it boiled down. From what I've seen, maybe it's changed.
Jabber comment. Eric says it would be a distraction to put this work into the existing working group. The existing working group needs to finish their work. Putting this into an existing working group will slow down that group's work as well as delay this work.
Thank you. Fleming Andreasen. I'm also in favor of proceeding towards a working group. I agree that I think we need to have clarity on the scope, and I would encourage that we don't get scope creep in so we can actually achieve something in a reasonable time frame. So while I resonate with the comments that say that this is probably a symptom of a larger problem and we can expand the scope towards that, I would caution against doing that initially. Thank you.
Hi, Brian Trammell again. I jumped up just to say no, please do not reopen IPFix and do that work here. I think that there's no danger of that happening. The scopes are completely different, and it might be that when you guys do the architecture here, you find out that the benefits of using this thing that you already have on all the devices, IPFix, might be outweighed by maybe some of the patterns, the communication patterns you want don't actually fit the protocol. That said, I think that it does probably would have a benefit to have this be somehow split between sec and ops, to have an ops AD or to have an ops shepherd or a sec AD and an ops AD, or somehow this straddles very nicely sort of a cross area boundary. It's a very clear cross area thing, and with the whole, I guess we'll hear more about that on Wednesday. But this seems like a very good candidate for doing good cross-area work in the IETF. Just not an IPFix.
Noted.
Ed Lopez with Fortinet again. Yeah, I agree, Kathleen. I agree with your comment that I2NSF and this seem to be looking at two sides of a similar coin. We're talking. I2NSF I think is more interested in configuration provisioning of NSFs, where this is more about signaling and what to do. But I think there's going to be some crosswork. I mean, obviously some common ground between those two. I don't know if it should be one work group or two, but just a thought that there is definitely a correlation between the two.
Thank you. So I acknowledge the correlation, but I think the folks working on them are just focused on specific problems, and I think that would be pretty tough. And Dan's been helping to co-chair the BOF for I2NSF, so he wants to add some things, it looks like. So I'll let him speak, and then I may add a little of what I was saying.
John Ramashkano speaking as co-chair of I2NSF. Please do not add use cases and a different type of interaction from an architectural and requirement point of view to what we are doing. So we have been kind of making great efforts to kind of focus the scope and define a workable charter. I believe that coming now in the reopening, the full scope discussion would actually delay both the approval of I2NSF, and actually I believe that it would do also a disservice to the DOTS problem space.
So I agree, and there's enough separate people interested in each of the efforts with some overlap that the folks with the overlap can help.
Melinda Shore on the related, well, the same topic. It's not just related. I think that largely I2NSF remains pretty deeply in the weeds, but there is a use case here. The problems are orthogonal. There does need to be some sort of back-end interface, right, once the threats have been identified and the information's been communicated. And there may be a role for I2NSF there. It hasn't come up to my knowledge in I2NSF discussions, but maybe it's something that should be considered.
So the mic lines are empty. We've gone through our questions. I think we're done. What I'd like to see next, I think, is discussion on the mail list. And if you guys think that there's enough interest in a specialized working group on this, draft charter text to be talked about on the mail list is the way to get there.
Thanks, everyone.
No, you do. It's extremely simple. How are you? I am accumulated a lot of that. Thank you. Plus the dot spot. I have to tell you, this morning. Can I say? Yeah. See the text. This will be when you put a draft. Yeah, right.
What he said. No, actually, no. Said that.
No. Finish this draft.
Wait, isn't that just yeah?
No.
Yeah.
Oh, blue sheets. Who has the blue sheets?
Do you have one?
If anyone has the blue sheets, could you please bring them to the front?